Hi, today we are going to learn algebra.
Teacher, what is algebra?
I won't tell you now. Let us get started with this example first. Eileen has 20 more stems than Zakia. If Eileen has 50 stems, how many stems does Zakia have?
That's easy. 50 minus 20, which is equals to 30. Zakia has 30 stems.
Okay, now if Eileen has 100 stems, how many stems does Zakia have?
It should be 100 minus 20, which is equals to 80 stems. Zakia has 80 stems.
Good job, Turbo Girl. Now, suppose that Eileen has a certain number of stems, say X stems. How many stems does Zakia have?
That's not easy. Let me think it over. When Eileen has 50 stems, I subtract 20 from 50 and get the number of stems Zakia has, which is 30. When Eileen has 100 stems, I also subtract 20 from 100 and get the number of stems Zakia has, which is 80. In the same way, if Eileen has X stems, I am supposed to subtract 20 from X stems. Wait! I am confused. How to express Zakia's stems in this case, as we don't know how many stems Eileen has?
You have answered your own doubt, Turbo Girl. In learning algebra, we use letters to represent unknown numbers to solve problems. Here, we use X to represent the number of stems Eileen has and X minus 20 to represent the number of stems Zakia has. Now, if Eileen has P stems, how many stems does Zakia have?
That's easy. She has P minus 20 stems, teacher. Does it mean that we use any letter in the alphabet in place of unknown numbers?
Clever girl! You have said what I want to say. Now, try this question. Alex is 7 years old. How old will he be in X years' time?
That's easy. It is the sum of X plus 7. This is the answer, right?
Well done. We have learned the addition and subtraction of letters and numbers. Now let's move on to the multiplication and division between letters and numbers. Let's look at this question. A basket has 5 apples. Can you tell me how many apples are there in n baskets?
That's not difficult. 2 baskets will have 5 times 2, which is equals to 10 apples. 4 baskets will have 5 times 4, which is equals to 20 apples. Working in this way, n baskets will have 5 times n apples inside. So, 5 times n stands for the total number of apples in n baskets.
Good answer, Turbo Girl. Generally, we write 5 times n or n times 5 as 5n. In writing algebra, we always put number in front of letter. Therefore, we write 5n and not n5. Also, bear in mind that 5n stands for n plus n plus n plus n plus n, not 5 plus n.
It's quite interesting. Now, I know what algebra is. I am ready to try another question, teacher.
Here is the question. Turbo Girl has 8 identical boxes of candies. If there are X candies altogether in the 8 boxes, how many candies are there in a box?
This is simple. I only need to divide the total number of candies by the number of boxes to get the answer. So, the answer is X divided by 8.
Good. But usually, we write X divided by 8 in fractional form for algebra. So the answer should be X over 8. Now, if there are Y plus 4 candies in 5 boxes, in each box there will be Y plus 4 over 5 candies. Let us try another one. A side of a cube is Y centimeters. Find the volume of the cube in terms of Y.
I know, teacher. The answer is y times y cubic centimeters. Can I simply write 3 y's together, teacher?
Good try, Turbo Girl. But we don't write y as the answer. Since y times itself 3 times, we use index form to represent the answer.
What is index form, teacher?
Here it is. We put 3 in the upper right corner of the letter y to show that y times itself 3 times. We read it as y cubed.
That's much simpler, teacher. So if y times itself 10 times, I don't need to write a very long expression. Instead, I put 10 in the upper right corner of y like this.
Clever girl. We will now learn how to simplify algebraic expressions.
Oh, we must express algebraic expressions in the simplest form, right?
Yes, clever girl. Can you simplify 4y minus 2y, Turbo Girl?
That's simple. 4y equals y plus y plus y plus y, and 2y equals to y plus y. I take 2 y's from 4 y's, I am left with 2 y's. Therefore, the answer is 2y.
Well done, Turbo Girl. We also do it in this way, as 4y and 2y are like terms. We only need to perform subtraction on the numbers 4 and 2. 4 minus 2 makes 2, so the answer is 2y.
Hold on, teacher. What are like terms?
Observe 4y and 2y. Do you find any similarities between 4y and 2y?
Let me see. First of all, both of them are products of numbers and letters. Second thing is the letter in both algebraic expressions are the same. It's y.
Very good, Turbo Girl. Since 4y and 2y share the letter y, we call 4y and 2y like terms. To do addition and subtraction on like terms, we only need to add and subtract the numbers in front of the letter. For example, to subtract 3e from 8e, we need only subtract 3 from 8, which is equal to 5. Then we put e after 5 and get 5e as the answer.
I see, teacher. The operation on like terms is the same as that on numbers.
Clever girl. Now, simplify 7y minus 4y plus 10y.
7y, 4y, and 10y are like terms. So, I only need to look at the numbers in front of y. 7 minus 4 plus 10 makes 13. Finally, I put y after 13, so the answer is 13y.
Try this one. Simplify 6a minus 2a plus 4.
I know that 6a and 2a are like terms. 6a minus 2a makes 4a. But how to perform operation on 4a and 4?
4a and 4 are not like terms as 4 has a letter after it. We call them unlike terms. For unlike terms, we just keep them as they are in the answer. So, 4a plus 4 is the simplest form for 6a minus 2a plus 4.
I think I can simplify algebraic expressions now, teacher.
Good girl. Try this one. Simplify 4 plus 3k plus 5 plus 2k.
That's not difficult. First, I add up like terms 3k and 2k. The result is 5k. Second, there are two numbers. 4 plus 5 makes 9. Finally, let me look at 5k and 9. They are unlike terms, so I leave them as the answer.
Fantastic. We shall now substitute the letters with numbers in the algebraic expressions to solve problems.
That shouldn't be difficult.
Turbo Girl, find the value of n plus 5 when n is equals to 6.
I know. I will put 6 in place of n and rewrite the sum as 6 plus 5, which makes 11. That was easy. Let me try another one.
Okay, the side of a square is x centimeters. There are 6 identical squares. What is the area of these 6 squares in terms of x?
The area of a square is x times x. That is x squared. There are 6 squares, so the total area is 6 times x squared, which is 6x squared.
Now, if one side of the square is 4 centimeters, what is the area of 6 squares?
I know. I substitute 4 into each occurrence of x. The total area is 6 times 4 square. 4 square means 4 times 4. So, I have 6 times 4 times 4. Working it out, the answer is 96 square centimeters.
Very good. The last part of the lesson is to solve word problems using algebraic expressions.
Okay.
Mr. Lee has X dollars. Mr. Tan has twice as much money as Mr. Lee. If they have $600 altogether, how much does Mr. Lee have?
Mr. Lee has X dollars. I draw a bar for him to represent X dollars. Mr. Tan has twice of X dollars. That is 2X dollars. I draw 2 bars for him to represent 2X dollars. Altogether, they have 2x plus x, which is equals to 3x dollars. Now, they have $600, so 3x is equal to 600. Therefore, x is 600 divided by 3, which is 200.
You are correct. Mr. Lee has $200. Let's try one more question. Mr. Lee has $50. He gave X dollars to his son. The remainder was then shared equally between his 2 daughters. Number 1, express each daughter's share in terms of x. Number 2, if x is equals to 14, how much money did each daughter receive, Turbo Girl?
After giving money to his son, Mr. Lee has 50 minus X dollars left. So each daughter will receive 50 minus X dollars divided by 2. Since X equals to 14, each daughter will get $18.
Well done. Turbo Girl, can you tell me what you have learned today?
I have learned how to use a letter to represent an unknown number and form an algebraic expression.
How do you simplify algebraic expressions, Turbo Girl?
Collect the like terms together and perform the operations as with numbers, then give the answer together with the unlike terms.
Very good. You have also learned how to substitute letters with numbers in algebraic expressions to solve word problems. Excellent. See you next time.